In today's video, I'll be introducing you to one of our latest Fischer Tropsch units. This is a multi-purpose FT pilot scale rig that we've made for a client, which is primarily interested in researching the ability to convert CO2 to eFuels via the Fischer Tropsch process. So at the front end of this unit, we have the ability to mix a variety of typical synthesis gas components like carbon monoxide, hydrogen, but you can additionally add CO2 because we want to valorize the CO2, which is preferably captured in a process upstream of this. The gases are mixed with our ratio controller to give us a predefined mix with the right concentrations. Downstream of this, we then have basically 3 different reactors to choose from. So the client is particularly interested in studying the ability to support highly active exothermic FT catalysts on structured surfaces. And by doing so, they can get high conversions, manage the heat at the same time, and have low pressure drops. So for that, we have one large diameter single fixed bed reactor here where you can really put in large monoliths, foams, whatever you're interested in. In addition to that, we want to be able to benchmark those catalysts against the performance of typical extrudates. Here we have a 2 parallel fixed bed system here. It's 2 parallel because we want to have a comparative amount of active catalyst mass in both, but the extrudates, because of the high exothermicity, need to have smaller reactor diameters. So we took that into account here to optimize hydrodynamics and make sure that we have heat management under control. The downstream product coming out of this is then a mixture of paraffins and water. This is basically the hot tail gas collection that we have on this side here. So this is our gas liquid separator here where we separate the paraffins from steam. Here we have the ability to take online samples during the course of reaction if we want. And in addition to that, we have the slop tank here from the burst discs and pressure relief valves. And here we have the ability then to collect and weigh continuously the paraffin which is produced during the course of reaction. I'll show you the third reactor on the backside, which is our slurry reactor, as well as the cold water workup that we use on the downstream side of this unit. This is the cold separation here where we're collecting all of the aqueous components. We have a cold gas liquid separator where we continuously collect the aqueous fraction here, weigh it for a tight mass balance. We can also take samples of the aqueous fraction here as well to see if any alcohols or any other water-soluble components are involved. We measure the off gases formed as well with a mass flow meter as well, so that we can really have a closed mass balance. The third reactor that this unit has is a slurries FT unit. It has all of the necessary internals to ensure that we have constant liquid level control and it doesn't block. So we can really operate a slurries FT unit with fine FT slurries catalyst without blockage over very long periods of time. We also have a nice system for closing and raising this, which is just a pneumatically actuated system here, much more ergonomically pleasant to work with. And it's quite a heavy reactor. You don't want to have people having to raise it lower by hand. So nice system here. The tail gas, the high and low temperature products coming out of this reactor, they all get collected in the same side as the Fischer Tropsch fixed bed reactors do. So basically the downstream of all these reactors is the same. And last but not least, which is important if you're doing slurry FT work, you need to be able to pre-reduce the catalyst. This is a fluidized bed reactor, which we have here. So you have the fine catalyst in here. You can't do that in a fixed bed reactor because the pressure drop is too high. So here with the fluidized bed reactor, we have a very nice isothermal reactor with low DP where we can pre-reduce catalyst, which we then transfer into the slurries reactor. And finally, we have a nice compressor system here where we can then recycle the gas continuously over the reactors to really obtain a high integral conversion with maybe a lower conversion per pass. That can also be mixed with fresh gas as well, so we can compress the fresh feed gas with the recycled gas as well, send it to the reactors. So as you see, a very versatile system, which basically has almost every conceivable type of FT reactor other than an ebulating bed reactor in a single unit, so the client can compare many things back to back. If you're interested in learning more about how ILS can help you with your eFuels or Fischer Tropsch research, feel free to contact, and thanks for listening to us.